Comprehensive Review Assignment 5. This review will focus a lot on topography, which will be important when it comes to the comprehensive exam. Okay, let's begin with a little latitude and longitude. Remember that latitude are lines that are parallel to the equator, and we're going to have 90 of them north of the equator and 90 of them south of the equator. And then the longitude all intersect at the poles, and we call those lines actually meridians. So you have the prime meridian, that's the first of your longitude lines. It runs through Greenwich, England, and on the opposite side of the Earth you have the international date line, or the 180th meridian. Good. This assignment's not too difficult. It just asks you to put them in order from north to south. So I took it as start at the pole, work down. So you should have D, A, B, and C. Just look at what the latitude is, and you'll see that the highest latitude, 40 degrees and 6 minutes. Remember that degrees are broken up into minutes. That would be the highest of your choices. And let's review contour lines. Remember that contour lines connect points of equal elevation. You'll have an index contour, which is usually every fourth or fifth contour line that is definitely labeled and usually bold, which will help you to get reference back to your other contour lines rather quickly. You're going to have that hatched contour line that we call a depression contour. Remember that those will indicate that the terrain is actually sinking down, and in the case of concentric circles, right, like the circle that you see around A over here, if that was hatched, then rather than that elevation being 250, it would actually repeat the previous elevation, so you'd change that to 200. Alright, enough with that review. Let's move on. The contour interval for this map, 50 meters. To find the contour interval, you take two contour lines that are labeled, and then you figure out the number of contour lines in between. You subtract the change in elevation divided by the number of lines. Too easy. Right here, they're all labeled. So you just go 50, 100, the difference between the two, 50 meters. Okay. If that was confusing, go back and check your notes. We talked about this, we did a lab on it, multiple exercises for homework, so you guys definitely have the material there. Which represents the greater rise in elevation? Meaning, where's the steeper slope? Point C to point A, or point B to point A. And if you look, C and A are a lot closer together, so coming back to the definition of gradient, the change in elevation over change in distance, you're going to have a much faster increase in elevation over a much shorter distance, meaning that you're going to have a steeper gradient or a steeper slope. So the answer is highlighted here, C to A. The next one, which would be the easiest route for a relaxed climb, and why? Now this is actually why we kind of care about contour lines, because should you ever be out in the woods and you're looking down, you're like, hey, I want to get back to camp, or I want to go for a hike, you want to be able to read your contour lines. Nothing worse than trying to walk along and suddenly, hey, I'm up to a cliff, because all those contour lines are really close together. Whereas I want to get to the top of the mountain, what's the gentlest climb that I can do? And here, from A to E would definitely be the gentlest. Good. How much does each section of the map scale to the right represent? Remember, we use map scales to figure out distance on a map. This one says that that particular span is 250 miles. So you then look at how many segments are in there. I counted 5, so 250 divided by 5 would give you 50 miles. Each degree of latitude or longitude is divided into 60 smaller units called minutes. And remember that you can divide minutes into seconds. Works just like a clock. Alright. On a topographic map, the difference in elevation between two consecutive contour lines is called the contour interval. We've reviewed that previously, so I'll go to the next page. What is the longitude of the prime meridian? That would be 0 degrees. That is the starting point. If you go 1 degree to the east or 1 degree to the west, that actually changes the hemisphere that you're in. Remember that the northern hemisphere and the southern hemisphere are divided by the equator, which happens to be 0 degrees latitude, and the eastern and western hemispheres are divided by the prime meridian, 0 degrees, or the 180th meridian, the international date line. What is the latitude of the North Pole? That's going to be 90 degrees north. 90 degrees north. South Pole would be 90 degrees south. Alright. Areas of equal elevation are connected by contour lines on a map. That's why we have the contour lines, because anywhere along that line is that set elevation. And if you're looking to have a relaxing hike, you want to walk around, but you really don't want to change elevation too much, right? You don't want to have to walk uphill, or you start walking downhill and now you got to go back uphill. You look to stay on one contour line, and you're going to have a pretty easy day. Index contour lines help to find elevation of nearby contour lines. On a real map, they do not label every contour line. So instead, they use every fourth or fifth contour to speed things up, to help you get a quick reference, and every fourth to fifth seems to work really well. Alright, now we're going to match the diagram with some of these descriptions. 0 degrees latitude splits the Earth in half, meaning the difference between the northern hemisphere and the southern hemisphere. So that would have to be A. That's the equator. That line next to A is the equator. Falls between 0 degrees and 180 degrees longitude. That would be D. That is just one of the meridians. No particular meridian of any significance, but hopefully you guys could understand how you separate them. 90 degrees latitude, location of one of the poles on Earth, and that's B. That happens to be the North Pole. Runs parallel to the equator. That has to be a latitude line, and that would be C. If you mixed up A and C, well, read the question a little more carefully. It has to run parallel to the equator. It cannot be the equator. This next one I really like because it gets you guys thinking. There's a mistake in the topographic map shown in the figure below. Highlight the mistake and explain why it is wrong. Well, I couldn't really highlight, so instead I drew a nice little circle around it, and you'll see there that two contour lines intersect. Now, if each contour line is a different elevation, well, then we can't have the lines overlap, because you can't have two different elevations in the same spot. Now, some of you might be saying, well, what if there's like a cliff with like an overhang? There's actually a hatched symbol that you would actually need to use there, but that's way beyond this course. And more importantly, not covered on the comp. Let's move on. Alright, a little more practice doing latitude and longitude. So it asks the latitude and longitude of point A. Came up with 30 degrees north. Remember that we always tell our latitude first. And then the longitude, 90 degrees west. And the latitude for point B would be 60 degrees north and 90 degrees east. Hopefully you picked up on the fact that the far left side of that diagram was the eastern hemisphere. There's the international date line labeled in there at 180 degrees. Alright, let's do a little bit of faulting. Key points to remember with faults: we want to identify where the hanging wall and the footwall are when we're looking at our dip slip faults, or as you guys more comfortably call them, a normal fault and a reverse fault. And then a strike slip fault, remember that's always in the horizontal plane, and you're always going to see the right angle. The right angle. So, let's run down. Fault is caused by compression stress, meaning that you're squeezing together, right? Like when we make a snowball, you're squeezing it together. So that would have to be C because you're shortening it. If you think about those two blocks, you've now pushed them together, you've squeezed them together. That's compressional stress. Alright, strike slip fault would be A because you see that 90-degree angle, you see the nice, basically two squares sliding alongside one another. So that would be in the horizontal plane. Hanging wall moves upward. That's going to be C because that is, of course, a reverse fault. B is a normal fault. B is also caused by tensional stress. We're stretching it out. We're pulling it apart. So that's tension. Remember the tension, for those that are familiar with string instruments like the guitar or violin, right? The more tension you put on the line, that's how we tune a guitar, right? We stretch the strings to get the pitch that we want. Alright, causes movement in the horizontal plane. Again, horizontal plane, strike slip fault, it's got to be A. Reverse fault is C. Remember, if the reverse fault angle is less than 45 degrees, it's a special type of reverse fault that we'd call a thrust fault. Right? Fault caused by shear stress. Shear stress is going to be like a scissor, and that is going to be A. Hanging wall slides downward. That's B. This is, again, a normal fault, and the hanging wall, which in this diagram is on the right. Note, in this diagram is on the right. I could draw it the other way, where it's on the left. You guys always have to pay attention to what way the hanging wall is moving to identify that, again, that's a normal fault. And then stretches bedrock, that would certainly be tensional stress, so that has to be, again, B. A few little points to finish up with. Thrust faults occur when the fault plane is less than 45 degrees and the hanging wall slides up with relation to the footwall, of course. Joints are cracks in bedrock where no movement has occurred. Faulting results from compressional stress causing ductile rocks to bend. Remember that faulting is a type of ductile or plastic deformation. It's not elastic deformation like the elastic rebound theory. When you take the stress off of an elastic deformation, it goes back to its original shape. And it's not brittle deformation, because we know that brittle deformation means that it actually snaps. Good. Syncline is a downward fold in rock layers. If it's an upward fold, we call it an anticline. And if it's just one little offset, we call it the monocline. Folded mountains are mountains formed at collision plate boundaries. So again, you have that compressional stress when two continental plates are coming at each other. So there's no subduction involved here. Two continental plates are going to suture together in what we call an orogeny. It's a mountain building event, and you're going to get a folded mountain. That is what a lot of the mountains in New York State look like. So when you're driving on vacation this summer, look out the window, you're going to see plenty of folds in the rock layers. Good. Domes are nearly circular folded mountains. And again, go back to your notes on folds and faults, and you'll see the little pictures of domes. Lastly, caverns are the result of water passing through fractures in limestone. Let's recall that limestone will dissolve in a mild acid, like a carbonic acid. And carbonic acid forms in rainwater when water passes through the atmosphere. picks up the carbon dioxide, now making a carbonic acid that will start to dissolve the limestone as it passes through the cracks and the fractures. That's where we're going to get our caverns from. That's where the deposits, because remember that limestone is CaCO3, or calcium carbonate. The carbonate will go away. The calcium gets deposited as dripstone, and if the dripstone is forming on the ceiling, we call it a stalactite. If it's dripped on the ground and then deposit, we get a stalagmite. And if those little cracks get to be too much, you can end up with a sinkhole. Very common feature in what again is known as a karst topography. So I hope this review helped. Happy studying.